Alrighty, this is an experiment I'm about to do that relates to these disastrous Dutch-style bicycle lanes. And my contention, I mean, I've sort of discussed this in many other places before, but this in particular relates to the noise and the pollution, right? So I mean, you know, you have a Dutch-style segregated cycleway. It doesn't significantly reduce the noise or the pollution, because the pollution, they drop not as 1 over r squared, it's 1 over r. And the rationale for this, I'll draw a simple diagram. You know, let's say you've got a car here, right, and it's driving along, you know, a crude kindergarten style car. You know, you got the exhaust pipe here, it's you know, letting off the exhaust here, so it's moving along here. And so right behind it there's another car coming, you know, it also has an exhaust, and it's also letting out exhaust, you know, and then behind it there's another one, you know, more exhaust, right? So in other words, the 1 over r squared law, it only applies when you can approximate your source as a point. And so here it's much better approximated as a line, at least if the traffic is heavy. So that means you've got a 1 over r law. And the rationale for that, you have to integrate, right? And there's a sort of a diagram here. You have to integrate the line as a series of point sources, right? So here's your series of point sources, your line. There's your measurement point, right? You know, you've got your r here, and you know, the integral is very easy to write down. It's not a trivial integral to do, but you know, you look it up in the integral tables, it'll show you. All right, so oh yeah, there's another point related. So I've got here a consumer grades. So this is the reason for the camera. Consumer grades sound meter. I think it will be less apparent for sound than for pollution. But of course, a sound meter, you know, it's all standard electronic components. You know, you can get these things very cheaply. I think this was $35 or something like that. So a CO2 meter is going to be a lot more expensive. So let's see here. What else did I want to point out at the beginning? Yeah, so the guideline, I'm thinking, okay, if you're going to make a cycling facility separate from the road, you make it completely separate. You give it its own right of way. So then not only have you know, you got no cars in your lane, you know, you don't have to share the lane or the surface. You've got none of the noise and pollution. So yeah, so one thing about this, yeah, of course it's decibels. That's a log. I think there's a factor 20 in there, right? So so essentially, yeah, I mean, anybody who's done science where you plotted log graph, what is it? The slope is the power, and the intercept is the coefficient. So of course we're not going to get a 1 over r law here. We're going to get something, actually it's a log. We're going to get a log value. But I mean, think about it. You know, you measure your distance. You know, when you're really close, a small amount is going to make more difference than a large amount. So I mean, you probably want to have a log scale anyway with your distance. Okay, so anyway, so let's gather together our bits and pieces. We got some chalk here to mark our things, mark our position, and measuring tape to figure out where it is. I don't know how I'm going to do this chalk. Put it in. I got an old rag here. I can throw it in there. So what else have we got? We got a consumer grade. I guess I don't need Measuring tape. I think that's everything. I guess I don't need the notebook. Alright, I think we're good to go. And we can start measuring. So it's a rush hour. Dog days of summer. I'm sweating like a pig here. And we've got a nice spot here we're going to measure. I think I'm going to measure a minute at each distance. Mark the distance. So let's get going. What have I done with the car key? No, I've not got the car key. Here it is. So I think I'm going to do it once on the near side. It's a single lane. People are going west. They've made some rubbish bike lanes, which I don't, again, the style I don't like. Oh, we can go to Burger King for lunch afterwards. Woo. Oh, time this, right? So it's only 5 meters. This. So here's a good spot. So we're coming. Shock ready. Some dumbass is going the wrong way. Damn. Okay, that's no good. Oh, I got it to catch. Okay, that's good. And make sure. Cut off each meter. Set for 60. Oh no, wait, we want. Okay, 400 here. 300 here. 200 here. Oops, damn. 30, 60, 90, 100. I may have to skip that. Okay. Oh, that's a nuisance. Okay, we'll do a half meters here. And okay. So let's see if we can get it further. That's about 5 meters. Okay. Alright, now we can start the experiment. We'll do a minute each. From somebody on a bicycle. Now, I sort of want to face towards traffic, but I think I'm going to have to face away from traffic so I can watch out for bicycles. So, well, why don't we start at the furthest so I can get, and we want a slow integration time. the other thing. We have to make sure that I'm looking at actually seeing the... Yeah, that's 1 minute. Next position. Okay, that's at least a minute. People go. Okay, that's at least a minute. Now we're on the bike lane, fortunately. So I've lost count. I think that's a minute. Alright, so now I have to go in the bike lane. Bother. Keep it up high so I can see. Yeah, there's a real issue with traffic levels here, that they're quite variable. That's a minute. Alright, so now we want to go right to the edge here. That's a minute. I don't know, I'm going to do these ones over again because the traffic levels were so low. We need consistent traffic levels to get a good everybody's slowing down because they think I'm holding a speed gun or something. Okay, I think that's a minute. See if I can go, I can go further out here. What I'm doing. Quiet, you'll ruin the experiments. Alright, let's see here. Measure here. Okay, that's about a meter there. One more position. Let's have a look here. Okay. So I think that's a minute again. Okay, so hopefully that's, I think I'm just gonna do that one experiment. I don't know how it's gonna turn out. It's you know, the sound levels are so variable. A bus comes by, you know, the sound levels go way up. I mean, you know, so I have to sort of see how I'm going to analyze the data. I mean, I suppose the best thing maybe would be to just get random samples from each of the positions and do it that way. But yeah, so I'll see how this little experiment works out. I suppose the ideal thing would you'd have a sensor at each point, and they'd be putting it into a computer. But unfortunately, I don't have that kind of equipment. This is citizen science here, and I don't have the money for that kind of equipment. But yeah, we'll see if we can get anything useful out of this little experiment. Anyway, have a good one.